Okay. My name is Samuel Iglesias. I'm an employee of Igalia, a member of the graphics team. Last year, I started contributing to Mesa. When I was developing the patches and doing some new features there, I realized that I need tools to check that I was not breaking anything that was already in place. And for that, for what I learned with that experience is the reason of this talk. But let's start from the beginning. The OpenGL is an API for rendering 2D and 3D graphics. It was originally designed by Silicon Graphics, but nowadays is managed by a non-profit technology consortium called Khronos Group. It's widely used in different form-factor devices, PCs, tablets, mobile phones, embedded devices. It's used for running applications that need 2D and 3D graphics rendering, most of the times because they need hardware acceleration, such, for example, games, scientific applications, etc. But as I said, OpenGL is only an API specification. The implementors, for example, NVIDIA, Intel, or for example, the open source world, Mesa, or any other open source drivers, are free to provide their own libraries and their own kernel drivers and so on. So there could be incompatibilities between those implementations and the OpenGL standard. So to check if we are if these drivers are following the OpenGL standard, there is these OpenGL conformance test suites. Of course, Khronos Group provides their own OpenGL conformance test suite, but although it's for free for software developers, it's not free software, actually. You have to agree, there is an agreement that you need to sign, and it says more or less that you have access to the source code, but the modifications that you do to that source code, you cannot redistribute it to third parties. So thanks to the community, we have unofficial free software alternatives for that cases. For example, this talk is going to talk about, is going to cover Gling, Draw Elements Quality Program, and Piglit. First one is Gling. Gling was created by 1999 by Alan Akin, but it was one of the first ones out there for OpenGL conformance. But what I have seen is that during the last years, there hasn't been much activity around Gling, and let's say this kind of abandoned project. But the good news is Piglit copied it, and now the Piglit community is maintaining this project and improving the test and adding new ones. As it is already part of Piglit, I am not going to talk much about it. I'm going to focus on the others. In case of the Draw Elements Quality Program, it was developed as a product of a Finnish company called Draw Elements. Last year, this company was bought by Google, and Google open sourced it as part of the Android Lollipop release with a Apache license to .0. This conformance test suite supports OpenGL ES 2.0, 3.0, 3.1, OpenGL, and EGL. The supported operating systems include Android, GNU Linux, and others. And recently, like 2 months ago, Piglit also added support for running the OpenGL ES3 tests from Draw Elements conformance test suite. The way to build it is you need to clone it from the Android repositories. Optionally, you need to add the following lines to the CMake list.txt, because the first two ones is because it is looking for libpng in specific library in specific directories, and if you have it already installed with the development packages on your GNU Linux distribution, you just need to tell it where is it. And the other lines is just to enable the debug build, because sometimes you really need to have access to GDB and run the GDB session to understand what the test does and what are the OpenGL calls done. Then you just configure it with CMake and make. Notice that it doesn't provide a make install target for make. So it is meant to be run inside of the build directory. Then you have two ways of running the tests. The first one is using the SX server. First step to use the SX server is create the list of tests that you want to run. For that, you enter in the corresponding module that you want to test. For example, in this case is OpenGL 3.0. With this command, you create a file that lists all of the tests that is gonna run. Then, once you have that, you launch the execution server, and in another terminal, you run the executor client. The executor receives different arguments. The first one is which binary is going to run. As following the example is the OpenGL ES3 test is the same binary that we used before. Then where is going to find that binary? So we specify the working directory. Then next step is you provide the case list, the directory, or where is the file that we created in the first step. And then you specify which kind of test you want to run. For example, here is all the functional OpenGL ES 3.0 tests. Of course, you can use the star to specify that is all of the tests included in that category. Finally, you provide the output file where it's going to save in XML format all the results. I recommend you to add the last parameter because these tests, they usually, not all of them, but they usually generate 3 images as a result. The 3 images, the first one is the one rendered by the OpenGL driver, the second one is the reference image, and the third one is an error mask, which is the difference between the render and the reference one. These images are saved inside the XML file as base64 strings. So, for example, as these functional tests, they are more or less, I think, more than 41,000 tests. You multiply them by 3 images and then the size of each images, and you realize that at the end, the XML file is going to have a huge weight. This is an example of this XML file. You have the name of the test that is run, and among other information, you have the time, the execution time, and the status, for example, is if passed, failed, or whatever. If you don't want to use the execution server, you can use just directly the binary. For example, for this case, we are running the same examples as before, the same tests as before. And the difference is here the XML file is, the name of the XML file will be testresults.qpa. The format is exactly the same. But in this case, the screenshot shows you shows you the base64 images that is going to generate. As there is more information that maybe you could be interested to check, I have it actually here. For example, this is the whole result of running one test. That is the functional fragment out the random 15. It says the name of the test, the shaders that is going to use, the vertex shader and fragment shader. And then the log information about if the compilation was fine, if the links, the linking was fine also. And for example, it says the PNG, the image is actually a PNG image. The string is actually a PNG image. So how do you convert it? How do you convert it to an actual PNG image? You can use a lot of tools. There are some of them available online. For example, this is a website, a64-image.net. And then if you copy and paste them, you will receive these three. You will have these three images. First one is the result of the test. The second is the reference. That is a gradient color between black and red. And then the error mask that shows you if the differences. If it's green, is fine. If it's red, is bad. Sometimes you only look at the error mask because the differences between two images are very subtle, maybe a few pixels, and looking at them sometimes is very hard. So the error mask is very useful for that cases. Then the XML files, as they are not so easy to sometimes to read. You need to, if you have a lot of them, you need to parse them to check which tests actually failed. There are some conversion tools. For example, this is the one that converts the XML file to a CSV one. But there is no HTML output or any other kind of output that could be more human readable. But the good thing is, as Piglit already 2 months ago added the support of running the EQP tests, we have such information. So talking about Piglit, it was created in 2007. It's widely used in Mesa for testing and development. It includes tests for OpenGL, OpenGL-ES, OpenCL. But if you want to build it and install it on your system, you need to fulfill these dependencies. The first one is the Python 2.7, then the Python macro module that creates source files according for templates. You have the NumPy, CMake, GL, Glue, and Glue libraries and development packages, X11 libraries and there. And usually, if at least in Debian-based distributions, Waffle is not part of the repositories. So you need to install it, build it, and install it on your system. Once you have everything, just build Piglit on your system is very easy. Cloning for the repository, configure it, and make. It has the install target, but usually you run it from the build directory. Then the first step you need to do is check the installation if everything is fine. So you need to run the Sanity test profile. I'm going to explain later what a test profile is. And if everything goes fine, you are ready to run your first complete Piglit test suite. This just notice that the complete Piglit run is going to take a lot of time, depending of your system, of course. Sometimes maybe half an hour, sometimes 3, 4, 5 hours, or even a day. Everything depends on the GPU, the CPU, and all the extensions that your OpenGL driver supports. Once you have the results, that is, they are saved in a JSON format, you can process them and read them in a more, let's say, human-readable way. First one is the HTML output. So it generates a HTML website that I'm going to show you later. Then the command line output, and then also you have the CSV file creation. This is an example of the command line output. It specifies the name of the test, the result, if it passed, skipped, crash, failed, warning, whatever. And at the end, you have a summary of the run. For example, we have 25,000 past tests out of 35,000 ones. In case of the HTML output, I'm going to show you better in a website here. Yeah, here is more human readable because of different reasons. First one is you have the status of every test with different colors. You have green for pass, gray for skipped, red for failed, black for crash, orange for warning, and so on. And as you see, they are listed by or functionality or by extension or category, let's say. So it's easy to find which one you are interested on. But the good thing is you don't need to go through all the list, because most of the times you are only interested on the failed test. So you just go to the problem one, and here they are listed all the ones that have some kind of problem in the execution. Cool thing also is, okay, you know that this test failed, but you don't know the reason. So with the HTML output, you just can click on the status, and you see here what was happening there. For example, information was the execution time, then the standard output that says that there were some problems here with the expected values in specific pixels. At the end here, you have the environment variables that it used, the actual command that was executed, so you can copy and paste it and execute it standalone. And the last part is the DMES output information if you enable it on the Piglit run. This DMES information is the difference of the DMES output before and after execution of the test. So you can, if you are testing your kernel driver, you can realize if this test was causing a specific kernel oops or whatever. Okay. Yeah, as I said, you just need to copy and paste the command, and you will have the same output. There are different ways to tailor your Piglit run. The first one is enable, for example, the DMES information. Another one is being verbose. This is very useful because some tests, some OpenGL drivers produces GPU hangs, and sometimes the screen completely freezes. So you need to do a hardware reboot. What this verbose helps you is it is listing the name of the test that is executing on runtime. So once you have the screen completely freeze, you just need to look at the last one, and most likely is going to be the culprit of this failure. You have more parameters for the Piglit run. You can run the tests all concurrently, or disable the concurrent execution. You can just test, for example, filtering by name. In this case, you pick from all the tests that Piglit has, you just execute the ones with texture, the word within their name, or excluding others because of that. For example, the second example is we execute all of them that has texture in their name, except the ones that also have a color word in their name. The problem of this is it's prone to errors. You can be mistaken very easily. It's quite cumbersome to write all of the sentence that when you have to run some specific test is quite complex. So the existence of the test profiles. Test profiles is just a list of tests that Piglit is going to run. For example, we already saw two of them. One was the sanity test. The other is all tests. They usually import other test profile and modify it by removing or adding new tests. But it's not always the case, as we are going to see in a few moments. They are written in Python, and this is one example that I actually did for one patch that I was testing on Gallium LLVM pipe. The first half of the file is exactly a copy of the GPU profile. As you see, it says from test.quick import the profile, so it imports the quick test profile, but it removes all of the compiler tests, and also you can remove them by extension, or like I did at the end, you can remove them just one by one. This case, I removed them because they were taking too much time on Gallium LLVM pipe, but you could have another reasons to do that. As I said, these test profiles are written in Python, so you can actually run, you can actually create your own test profile that does something completely different than import and remove and this stuff. This case, in DQP GLS3, actually, Chad Versas from Intel created a test runner for DQP GLS3 tests. The way to run it is quite simple. You need to just provide where the binary is in an environment variable, and then as following the same way that we already saw, is you just specify the DQP GLS3 profile, then following the examples of the few slides before, the same functional OpenGL ES3 tests, and then you save it in a JSON format file. Then you can process it, and instead of generate an HTML output, and instead of having a XML file and you need to open it with your favorite editor, you can just use your browser, and as we see before, just click on one of them, and you have exactly the same information as before. The only problem I see with this is that the logging images is disabled. So if you see a failed test and you want to check what was the result, the image resulting of this execution, you just need to execute it by hand inside of the QP. So as a conclusions, OpenGL is just an API. The implementors have the freedom to create their own solutions, so they can be compatible with the standard. Khronos provides their own official OpenGL conformance suites, but there are unofficial free software alternatives such as Glint, DQP, or Piglit. If you are considering to start contributing to Mesa, or you want to learn OpenGL, I recommend you to start looking at Piglit, their tests, because if you are learning OpenGL, their tests are very simple. They are focused on one specific functionality, so it's very easy to understand. And if you want to contribute to Mesa, this is a good starting point because you execute the OpenGL conformance suite, look for failed tests, and you start just analyzing and debugging the problem until you have a patch to send to Mesa. So this is all. Questions? Yep.
Not so much a question, more an advertisement. Brian has an extensive test suite for direct per gig and through our directly to OpenGL mapper. This also can be used to test OpenGL implementations. It has some disadvantages. For example, it's more difficult to read since the actual tests running are written in direct per gig. But the other advantage is that pretty much every single one of those tests tests something that an actual game needs.
Mm-hmm.
So those were written to find out how we are supposed to behave to fix that game.
Yeah.
So if the test flags a failure, then probably one or another game isn't running on the driver.
Mm-hmm.
Did someone compare the proprietary tests from the Khronos Group with Piglit or one of the other test suites to see if they produce the same result?
Yeah, for example, when I find a failed test, and sometimes it's because the test is actually faulty, because it doesn't follow exactly the specifications, or sometimes is intended. So you test also with NVIDIA or whatever, and then you see, I mean, if you see that most of the proprietary drivers are doing one way, maybe you can realize that the problem is within your driver, or maybe they are completely wrong with the specification. Yeah. Okay.
Are your slides available anywhere?
What?
Are your slides available anywhere?
Online?
Yeah.
Yeah. I'm going to push them right now. Yeah.
Great.
So this will all be on the browser website. If somebody gives you slides, then what will be put on the browser website? Actually, the speakers will be able to do that, are able to do that themselves.
Okay.
It will be linked off the start page.
Yeah. Okay. Okay. Thank you.